grade 12s. As I told you, the next lesson will be focusing on IUPAC naming. Hence, in notes, that page for you to read the rules. Siyavula, that textbook. So, all the definitions that are here are from Siyavula, or the rules. This is what Siyavula. So, basically, let's go back to subsequent, because I remember giving you subsequent, and I said the next lesson will be starting with that subsequent, explaining it again. So if we read up, a substituent is an atom, or a group of atoms bonded to a carbon chain. A carbon chain. This can be an inorganic atom, such as a halogen, or an alkyl group that is shorter than the main group. Yeah? So there are two types of substituents. It is an atom or a group of atoms, and then that is bonded to a carbon chain. We can even say to a main carbon chain, just to emphasize that part. There's a main carbon chain up, and then there are substituents, additions, in other words. This can be an inorganic atom. Let's start here. Inorganic atom. So I did write here atom, what type of an atom that can be, and it is explained in the definition, e.g. halogen. So the halogens can possibly be bromine, can possibly iodine, fluorine, or chlorine. However, when we name them as part of that as part of that main carbon continuous chain, we will not be saying bromine, iodine, fluorine, chlorine. We rather will use the abbreviations ZAZO. So for bromine, city bromo. For iodine, city iodo. For fluorine, city fluoro. Then for chlorine, city chloro. Yeah. And then if ever that is an alkyl group, also if ever that the substituent is an alkyl group, it is going to be a short type, that is, it is a short chain, shorter than the main group. I'm going to do examples for you to see this. However, it is shorter than the main group. That's what is important here. So here, if you look at this side chain, or rather alkyl group, it's shorter than hydrogen here. It could have been in methane. But because now, let me write it here. Name ends with YL. YL, yeah. So suka YL, suka glando ba alkyl group. Alkyl group. Yeah, YL. So the name of this alkyl group is methyl. And then the name of this alkyl group, look at it. It could have been what if there was a hydrogen here? It could have been an ethane. But because there's no hydrogen there now, ethyl or ethyl, whichever you want. Now, I want to bring you back up with atom. If ever atom, again, emphasis, it will be, for our purposes, it will be a halogen, people. And remember the halogens, NP. Remember, the halogen are always a functional group. They also count as a functional group. Well, if you remember, a functional group is an atom, group of atoms, or a type of bond that determines the physical and the chemical properties of an organic molecule. So they still do count as a functional group. However, we classes bizayo kasi counter with chain later. City by substituent. Yeah. However, it's not a functional group, people. Not functional group. Very important. Are functional group? In other words, it wouldn't change the group to which an organic molecule belongs to. I am going to emphasize these class examples. There are plenty of examples for us to explore. So let's go. Before we start, we're starting in IUPAC naming rules. Nazi abantu, I did give you from I copied this from Siyavula textbook. Ne? I have mentioned the page number. You can also go there. And all the examples that I'm going to be doing here, Siyavula. And Payana Zipineza explain step by step, which I will also be doing. Yes. I'm hoping that we watch Jong's rules. So let's start with the first 3 rules. I'm going to combine them because I have already taught you how to name organic molecules. The first 3 rules, I know that I have used them. And I have 2 examples here, which I want to make a distinction. So let's start with the rule 1. Rule 1, recognize the functional group or in the compound. Recognize the functional group in the compound. Why? Because this will tell you about the suffix. In other words, about which homologous series this molecule belongs to. Because the ending name, if you remember, if ane, ending name, is alkane. If ene, is alkene. If yne, is alkyne. So very important, its suffix will be determined by the functional group. And the functional group you check in the chain. Yeah. So very important. If we go here, let me do it literally. I have 2 compounds here, compound A and compound B. So the rule number 1, let's apply it. Recognize the functional group. First of all, if you look at these 2 molecules, they are both hydrocarbons. Why? Because they only consist of what? Hydrogen and carbon atoms. Hence, they are hydrocarbons. Now, they can either be alkane, alkene, alkyne. And then we recognize, is there a special functional group here? So if we check for both molecules, there are double bonds somewhere in the carbon chain or the main continuous chain. Main continuous chain. So if you look at the main continuous chain, there are double bonds there. 1 double bond for each molecule. And then we go back to rule 2. Let's read rule 2. Rule 2, to find the longest, I think I just mentioned that part. Very important part, the longest continuous chain that contains the functional group. Yeah, you can read other examples when. Find the longest continuous chain that contains the functional group. I go to my 2 molecules. I happen to have 2 molecules that are straight molecules. So rule 2, both the chains are both the main continuous chain, people. I don't have extra chains here, side chain or the alkyl group. I go to rule 3. Rule 3, uti number the carbons in the longest continuous chain. The part I did mention, number the carbons in the main continuous chain, brackets, if I alkene, don't count it as a functional group because the functional group are alkanes. It's just those single bonds, people. I call special in that sense. Then the others are special in that double, triple bond or halogen. Anyhow, you need to start numbering so that the functional group is on the carbon with the lowest possible number. That rule is the main component. These 2 rules, rule 2 and rule 3, the main important part, we recognize the functional group for rule 1, rule 2, and then the longest continuous chain must contain the functional group. Then rule 3, number such that functional group occupies or has the lowest number possible. So let's go to these 2 molecules. If functional group is double bond, in other words, it must be occupied by the carbon with the lowest number. And if you notice, if I look at the symmetrical molecule, look at where the double bond is closest to. Is it closest to the left side or closest to the right hand side? And if you look at people, say left. So that's where we're going to start counting because it is closest to the left hand side. So when I count, I'm going to say carbon 1, carbon 2. Remember, the carbon with the lowest number possible is the one that we're going to mention for the functional group. 2, 3, 4, 5. Where is the double bond? The double bond is at carbon 2. Yes, it is between carbon 2, and 3. But the carbon that occupies the lowest number here is carbon 2. So we will say the double bond is at carbon 2. Yeah? And previously we said this is an alkene because it is a double bond. So now we ask ourselves, how many carbons are in the main continuous chain? Because that's going to help us to have the prefix for the main chain. So a prefix alapa, there are 5 carbons. So prefix alapa is supposed to be penned. So it's going to be penned. Yeah? Penned. Where is the carbon double bond? 3 are. This is an alkene. Therefore, what name is it supposed to end up with? E-N-E. Penned to in. And if you remember, alkene, the general formula would be CN. It was CnH2n. So for fun, if ever we want molecular formula, C, how many carbons? 5. H 2 times 5, 10. So if you double check from the structural formula, the molecular formula should correspond. So if you check Payana, there are 5 carbons obviously, and then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So there are 10 hydrogens there. So we check the compound B. If we go to compound B and we apply those rules, recognize the functional group. The functional group here is the double bond again. So if we go to double check our rules, and then the longest continuous chain, again people, I have not added alkyl groups here. So the longest continuous chain is that straight chain there. And then I must number such that the double bond, or in this case, which is my functional group, occupies the lowest number of the lowest carbon possible. So it's going to be, if I draw, and I look at where that double bond is closest to, if in the end I symmetrical molecule, if the double bond is closest to the right hand side. So when I count, I'm going to start on the right hand side because the double bond is closest to the right hand side. And this is going to be carbon 1, 2, 3, 4, 5. So this molecule also has 5 carbons. Because it has 5 carbons, what that basically means is going to have a prefix penned now. A double bond layer that makes this an alkene. So where is the double bond? Again, the lowest number of carbon possible. Let me check this. The lowest possible number, man. Yes. Look, the double bond occupies the lowest number possible. So it's going to be penned to in. So that's penned to in. Let me go back, people. I did not see my mistake here. I was supposed to say penned to in. So basically, both of these molecules are penned to in. Yeah, my mistake there. Penned to in. So again, since he penned to in, it should be C5H10. So basically, they are both the same molecule. People. So it's like uthatha pen yakho phinde iguqule ujongise left phinde iguqule ujongise right. Basically, this is the same molecule. But into ebalulekileyo is that besides noba ingaguquli ijonge phezulu like ijonge su okanye ijonge su, you apply the same rules, maybe horizontal, maybe vertical. You start on the side where the functional group is closest to, and you start by doing what? By counting such that functional group is at the lowest number possible. So, I'm going to use examples from Usiyavula because when I examples all the time, it takes time. Like it's going to be faster if I do those rules. So, but before that, I know that my examples also include rule 4. So, rule 1, rule 2, rule 3, rule 4. Very important, rule 4, I think I just mentioned rule 4, that if If ever now there's a branch, intoni branch people, a branch, the alkyl group. Sometimes it's the branch, sometimes the alkyl group, sometimes intoni is side chain. Yeah, this is the same thing. Eh? Alkyl group, side chain, branch, subsequent. It's the same thing, people. I don't know why there's so many words, but you often adapt. So, a branch basically a side chain or an alkyl group, ile methyl, nale ethyl, tinso sebenzis. I feel like man can't give example before. Let's take let me say C. Let's take this molecule 1, 2, 3, 4, 5, 6. Okay, let's put hydrogens there. Let's place hydrogens. So, if you look at my chain and recognize rule number 1, recognize the functional group. There are single bonds between the carbon atoms in this molecule. That makes this molecule an alkane. And because the alkane, the longest chain, continuous chain, is going to be the straight chain here, because I don't have substituents thus far. And then I don't have any special functional groups here. What are special functional groups? Again, double, triple bond, or halogen. For the time being, we'll add other functional groups as a. So if you look at this chain, again, I don't have to count which side is which, because upper is symmetrical molecule, and also there are equal number of, there are 6 carbons. So I will just say this is hexane. Yeah? Hexane. Keep that in mind because I'm going to erase. Now let's go back. So side chains. Now look at this thing. Let's go. I'm going to use the same color and add it somewhere in this hexane. So if ever I come to this molecule, erase here, erase here, and then it is C, CH, C, CH. So now what I have done in this molecule, I have essentially erased its name and replaced it with another one, because now, do you remember? This is a methyl, if you remember. The alkyl group is methyl. Therefore, now I have to mention that part about there is a what here? There is a methyl here. Where is that methyl? Kumbula functional group. It won't change physical and chemical properties. Because it does not change physical and chemical properties, it means still alkanely still. So you ask yourself, what would change physical and chemical properties here? It would be a halogen, people. The minute I put a halogen here, I have changed it. Now it's no longer an alkane, it's a haloalkane. But because I just put the alkyl group, does not change does not change the homologous series to which this molecule belongs to. It's still an alkane. Very important. And then I have to mention its position. So if you read, where's that rule? If you read this rule, I don't even know where is it's important. Important. If the molecule is an alkane, the branched alkyl group must be on the carbon with the lowest possible number. Again, we're still applying the lowest possible number. So we go to the chain that I have given you. So now let's look at let's make that alkyl occupy the lowest number possible when we count. And if you look at it, when we count from the left hand side, 1, 2, 3, 4, 5, 6. If we look at it, when we count from left to right, it is at carbon 4. However, When we count from this side, right, 1, 2, 3, 4, 5, 6. So if you count from right, it occupies carbon 3. Remembering that ngobe siqale left we occupy carbon 4. Bingu follow kasuka ngapha asiya ngapha. So basically soqala phika sibala soqala right owenzela rule yami just isike phakathi molecule yakho uyibona ba I closest kweliphi icala I substituent, i.e. the function, the halogen or the alkyl group. So now it's closest to the right. That means that it says carbon 3. And then now I must start naming by mentioning the position of that alkyl group. So I will say this is 3 ndoni methyl here. Methyl, ne? 3 methyl, but the main continuous chain, when I count, notice I don't count the carbon of the alkyl group. You do not count the carbon of the alkyl group. He branch on a side chain. You count the main continuous chain. That's what that means. Main continuous chain. Lena like it's an addition to the main continuous chain. So we do not count it as part of the main continuous chain. Anyhow, so we look at the number of carbons that are in the main continuous chain. It's 6. Kumbulu 6 itini prefix yake hex. Kumbule alkane, the alkane gqibela bani ngu ain, because there's no need to mention position of those single bonds zigcwele mos. Hexane. So this is a 3-methyl hexane. 3-methyl hexane. So that basically 3-methyl hexane. I am going to add now. The first one I'm just going to call it example 1 because there are letters there which are going to confuse me. Can't explain. So I'm just going to say 1 because those letters are repeating. So let's go to example 1. Here is example 1. Remember, these examples are additions to what I've explained. Again, this is applying up to rule 4. Ne? We still up to rule 4, where we are having what do you call it? Alkyl group or a side chain or a substituent. Yeah. So what is our substituent here? Again, let's go back to our rules one more time. Next time, I'm just going to move and explain. Recognize the functional group. Siepa. If functional group they are single bonds between carbon, all their carbon atoms here. This is an alkane. This single bonds, the functional group. And then we go to find the longest continuous chain, the longest continuous carbon chain containing the functional group. So in single bonds, you don't trace any functional group. And then see rule 3. Rule 3 says number the carbon in the longest continuous chain. Again, rule 2 no rule 3 apply. Let me write it here. Ne? Applies for double, triple bond and halogen. For people, it also applies for alcohols, carboxylic acid. It's going to apply for other things. I'm just explaining for the homologous series that I need you to know at the moment. Anyhow, rule 4 some apply because by a cookie branch. How do we recognize the branch now? Let's go there. Now we count people. We find the longest continuous chain. Very important part. Find the longest continuous chain. Find it. What do I mean by that? I mean, if I count from left to right, for example, and if I count from right to left, you will be met with the branch, if you notice. Ne? However, we can also treat this one as a branch. Why? Because there was good. 1, 2, 3, 4, 5. I have a what? Recognize. Again, ayizumane ibekele wena lento ibe vertical also. However, if I count from left to right, the branch, ndoni branch yethu kanini? Ethyl. Branch yethu ethyl, people. Let me write it here. Branch yethu ethyl. So the branch is at carbon 3. However, option 2, if ever I count 1, 2, 3, DT 4, 5, recognize again, you find ethyl again. This is still correct, people. Again, if ever I count starting from the right, 1, 2, 3, 4, 5, nansi ethyl. And then again, if ever I count 1, 2, 3, 4, 5, still ethyl. And notice ethyl is always attached to carbon 3. It's just special for the molecule, by the way. It's about complicated as and I'm going to show you. Anyhow, basically upper we have an ethyl at which carbon attached to carbon 3. It's attached to carbon 3, ethyl. Ethyl. So how do we name now? We are going to say where is the what is the name of the ethyl? I mean the name of the alkyl ethyl. Where? What carbon is it located at? 3. So did 3 carbon 3. There is a what? An ethyl. Ethyl, the main continuous chain. Leli. Kumbula, each branch does not count as part of the main continuous chain. So it's about 3 ethyl ndoni, 5 carbons in the main continuous chain. So pentane. See example 2. Example 2 is about complicated, increasing difficulty. Interesting. Yeah. Again, the two molecules, they look similar. But now, remember, Lena, alkane, Lena. Find the functional group, people. This is where it becomes important now. Rule 2, no rule 3. Find the functional group. So, functional group yalapa is a double bond, which immediately makes this molecule an alkene. Immediately, it makes this an alkene. Alkene that has a branch, people. How do I know that? Because one of these two has to count as a branch because they can possibly both either act as an ethyl. Why? Why not this one? Because, functional group. A functional group must always be part of the main continuous chain. Let's go to that rule again. Here is the rule. Rule 2. Find the longest continuous chain that contains the functional group. So the longest continuous chain must always be attached to the functional group. Always attached to the functional group. So this is where rule 2 applies very importantly. Find the longest continuous chain. So noba ndithe nali chain alarm. Ne? Or ndithi nali chain alarm. But notice that double bond must be part of that longest continuous chain. Part of the main continuous chain. Eh? Now, I have to start such that, if you remember, the functional group is occupying the lowest possible number, if you remember. That means it's compulsory for me to start because a functional group is closest to the left-hand side. So because it's at 1, 2. However, if we up 1, 2, 3, carbon 3. If we up 1, 2, 3. Basically, I have to start from the left, people. So carbon 1. So it's 1, 2. Now the question would be, do I go straight or do I go down? But if you notice, as carbons, these two side chains, they are equal in number. So I can go either way. Ndingaya straight or ndingaya down. Igama lizophuma lifana. Why? Because nansi lento 3 4 5 kwi-ethyl carbon 3 yayibo. Or I can go straight 3 4 5 again ukho i-ethyl phi ku-carbon 3, so it doesn't affect the name. Only when it's going to show up xa ibalulekile le rule. Anyhow, recognize the functional group double bond. Start numbering by doing what? Include that a functional group as part of the main continuous chain. Then number such that the functional group is at the lowest possible number. Yeah. And then if there's a side chain, now mention the position of that chain. Qala ngayo position yayo, chaze igama layo. So the name of that side chain is ethyl. Where is this ethyl? Coincidentally, it's at carbon 3 again. Ethyl. The main continuous chain has 5 carbons. Remember, as well as zonke side chain, we don't count carbons. So the main continuous chain has 5 carbons. So I'm going to say pent. I can't say pentane now. Why? Because there's a double bond here. Where? At carbon 2, people. Remember the lowest carbon possible. Ne? So ipently 2 in. Why in? Because the alkene igqibela ngo-ene. So basically this is a 3-ethyl pent 2 in. Yeah. Let's go. Do example 3. Let me just move it down. 1, 2, 3. 3. I'm going to move a little bit faster now. Upper, apply rule 1. Recognize the functional group. There's a triple bond. Kumbula branches also functional groups. Each functional groups is double, triple, ondoni, halogen. Because the functional group here is triple bond, that makes this an alkyne. Remember, I made a mistake in the alkyne. I have to be careful. The alkyne. Remember, when you number your main continuous chain, your main continuous chain must always include the functional group, people. Which means, suppose the functional group is a function, as not the chain the main continuous chain. Because the minute we are excluding that functional group. Hence, rules the longest continuous chain that contains the functional group. Which means I have put up 2 possible chains here. Either the straight one or the one that bends and forms an L shape that is inverted. Yeah. So now ask myself, I have to start closest to the functional group because the functional group must occupy the lowest number possible. So 1, 2, and then I have 2 possible sides here. But because either way, branches are lingana coincidentally again, I can just go straight, people. 3, 4, 5. So the main continuous chain has 5 carbons because that's the longest continuous chain that contains the functional group. Even if I had gone this way, I was going to have 5 carbons because this was going to be 4, 5, and this would be my branch now. This would be my branch. So either way, I get the same results. So now, again, there's a branch here. My branch is ethyl. Mention position yayo. Position of your ethyl will be carbon 3 ethyl. Ethyl. The main continuous chain has 5 carbons. So bani pent. But now this is an alkyne. Where is the double bond? At carbon 1, people. Carbon 1. 1 ine. So basically this is a 3-ethyl pent 1 ine. Carbon 4, example 4, as the science about without you bony pattern, and also you must read the rules. So 1, 2, 3, 4. Yeah, I definitely le uzayibona le somewhere testing. It's very popular, very common. I've seen it many times. Anyhow, 3 carbons. Again, when you count it continuously, talk continuously. Umzekelo mandicacisele into continuously ngathi kanti 1 2 3 this is continuously. 1 2 3 this is continuously. Uba ngoku ndifuna ukuthi 1 2 3 4 it's not continuous because ndihamba njani xa ndihamba ndithi gqamba ndithi I can't do that ne. So ifuneka kanamarisha such that umgca wami uyahamba engastopi people yabo angamane ezokwenza into ze-chess ahambe straight agobe down aye left aye right angenzi into efani. Anyhow, I hope le nto ka-continuous chain uyibambile. 1 2 3 sine-methyl P carbon 2. Ndiqale left 1 2 3 sine-methyl P carbon 2. Ndiphinde ndibale 1 2 3 sine-methyl P carbon 2. Ndiphinde ndibale 1 2 3 sine-methyl P carbon 2. Noba ndiyengaphi people yabo, I will have a methyl here. The results are the same because I'm just going to follow the longest continuous chain here. The longest continuous chain here can only have 3 carbons. And then the 4th carbon becomes part of a branch, side chain, subsequent, which is in this case methyl. Khumbule, this makes this an alkane, by the way, because there are single bonds between carbon atoms. So indoni le is by prop main continuous chain, but ngoku ufuna ndimenshine wena ntoni kanene, wena methyl ubuphi. So I'm going to say 2 methyl ndoni propane. I'm reminded now, one student last year gave me an idea to emphasize the party main continuous chain. So yeah, I'm going to show you another way of distinguishing or differentiating between the main continuous chain by ndoni le ndithetha ngayo. So I'm just going to make this example here so that uyibone. So if you look at this molecule, xa ndibalayo apha ndingaqala apha ndithi 1 2 3 4. Because benibala continuously apha, we can't say methyl people. Very important. And even if I start from the top, notice I'm going to say 1 2 3 4. Again, indoni lena main continuous chain yonke le, there's no methyl here yabo. So uzayibona njani methyl okanye ethyl? It is always attached to a carbon that is attached to 2 carbons. And I am going to, next time we do examples ndizaxela intoni igama le carbon, but for the time being the secondary carbon le because it attached to 2 carbons. So basically the secondary carbon is carbon ebambelele kwi carbon eziyi-2. And then no, this is a tertiary carbon le. I'm going to do this kansenze enye lesson people ne, because I can see it's going to introduce new complicated rules. You don't have to know it at the moment. However, what you must know, this is a methyl ne? 2 methyl propane. No, only single bonds between carbon atoms. I am going to come back to this thing of primary, secondary, tertiary carbon. Anyhow, let's do example 5. Example 5. I think I'm going to skip others. Ne? Example 5. Okay, let me do example 5 because now I want to emphasize something very important. So, again, recognize the functional group. You know, double bond, alkene. However, now we have 2 double bonds. Yeah? Let me go and check rules. I think there is the part. I'm going to to just zoom here. Whenever you have two functional groups ezifanayo, such as the double bond, the triple bond, or you have two halogens or three halogens ezifanayo in the same molecule, or four in fact, or you have two or three or four subsequents, sisebenzisa u-di, u-tri, u-tetra. Di, tri, or tetra. Ne? U-dicarbon dioxide. I hope uyakhumbula. U-di uthetha ukuthini. Anyhow, let's go back. So, i-alkene. Now, two functional groups, basically, find the one closest to the lowest number possible. If we start from this side 1, 2, you carbon 2, that double bond. However, if we start from this side 1, we are met with the first functional group. So that's 1, 2, 3, 4, 5. Very important. And then the stem or the main continuous chain here has 5 carbons because there's no branch here. I call methyl or ethyl here. So it's going to be pent. And then when we name the position of double bonds, so it's by pent 1 point or comma 1 comma 3, because one of the double bonds is at carbon 1, one of the double bonds is at carbon 3. Sitting Z2 as double bonds, so it's about di. Then igqibela ngabani i-alkene xa inimayo igqibela ngo-NENE, so diene. So i-pent 1.3 diene le. Siye kubani 6, example 6. Example 6, 1, 2, 3, 4, 5, 6, 6. Okay, I think you might have done this one. This one double bond, alkene again. Alkene, one double bond. Where at the first carbon? 2, 3, 4, 5. So that makes this one pent again. Where is the double bond? 1 in. Pent 1 in. Very easy. Say 7. Yeah, just slow down sometimes and explain 1, 2, 3, 4, 5, 6, 7. And so okay, uyaqala. Let me just enlarge this image because it's going to make it difficult for me to explain. Okay, now look at this chain. There are clearly branches here. No double bonds again. So, whenever you have two branches, start, especially if it's the identical, start in the side where the first branch is closest. So now up, remember continuously. Let's find the longest continuous chain possible here. Again, asinayo inansika functional group. So we can count well color from the left hand side. 1, 2, 3, 4. That results in me having branch ku carbon 3 and carbon 2. Remind you, carbon 2 and carbon 3. If I start from this side, 1, 2, 3, 4, again, it results me from having branch ku carbon carbon 2, carbon 3. Even if I start from this side, 1, 2, 3, 4, again, ku carbon 2 and ku carbon 3, I have branches, which are methyls, by the way. Even if I start from this side, 1, 2, 3, 4, I still have a branch, carbon 2, now carbon 3, people. So I can start whichever side, I say in the molecule. But I like to start from this side, 93, 4. What are my branches? Again, identical branches. Kumbula U2, theta ntoni ukuthi di. U3, tri. U4, tetra. For the what? For the same subsequent or double or triple bond, people. Apply with double or triple bond or substituent length. So I have the same substituent here, which is methyl. Remember, when there's a substituent, mention position yayo. So I'm going to start with the lowest number possible. Where is the first substituent? Carbon 2. So 2.3 di. Diindoni methyl ndoni bute because there are 4 carbons in the main continuous chain. Butane. Yabo. Again, main continuous chain 1 2 3 4 dibale continuously. If I'm going to city 5 6, that's not continuously, people. Yeah. Let's add 8. Example 8. Yeah, there's an increasing difficulty, so you need to go back if ever there's some complications. This one is a bit easy. 8. So I can just start. If you look at symmetry of the molecule, it branch collocated people. So I can just start 1 2 3 4. And then my branch is at carbon 2. What is the name of the branch? I mean carbon 2. Name of the branch, methyl. Methyl ndoni? Butane. Why butane? Because he alkane. Let's go to example 9. Example 9. I think this is example 9. Yeah, difficult. So again, we apply that rule. Rule 1, recognize the functional group. The longest continuous chain must occupy, this is the functional group. The longest continuous chain must have that functional group. When I count, it must occupy the lowest number possible functional group here, which means compulsory my carbon 1. Yeah? And then I count going to the right. 1 2 3. If I say this is 4, carbon 3, there is a methyl. If I say this is 4, carbon 3, still there is a methyl. Same results. So I'm going to count 1, 2, 3, 4. And then I start with the side chain. Very important, you always start with the substituent when you name. So at carbon 3, there's a methyl. And then 3 methyl, and then the main continuous chain has 4 carbons. 3 methyl, bute. Where is the double bond? Bute 1 in. 3 methyl, bute 1 in. Yes, bute 1 in. 10. Sesenzelo ne? Because I happen to, sesibalelwe apha. And I will just explain why balwe kola hlobo. Basically, the reason in carbon 1 lo is because even though we have 2 double bonds here, we have double bond double bond, and it could have been carbon 1 lo, it could have been, it is carbon 1. Why yellow carbon 1? Because now asymmetrical molecule, carbon 1 both sides double bond. So now what's going to take the second priority? It is the branch now. So okay, because a branch determine because it double bonds got carbon 1 both sides. Let's just say that must count closest to a branch A2. A branch A2 is closest to the left hand side. Hence in carbon 1 low. So when we name again a branch. Branch yethu ndoni ethyl ipi carbon 2 ethyl. Now main continuous chain has 4 carbons, so bute ndoni, remember the 2 double bonds. Let me remind you, when there are two double bonds, so to die people for 2. If you call carbon 1, SB carbon 3. and then stini di ntoni alkene lena ne alkene so ngu-di in so i-2 ethyl but 1.3 di in le siya ku-11 example 11 I think this is 11 okay triple bond people that makes it alkyne again and then because the alkyne lena so we will prioritize that double bond ukhumbule emphasis if I did not mention it double bond takes priority over i-alkyl group xa balayo qala yona qala ukuthi ufocus kuyo xa i-molecule yakho symmetrical so kasibalayo so kunyanzeleke siqale ngapha 1 2 because ku-carbon 2 la double bond yayibo ikude kasuka ngapha so 1 2 3 4 5 noba nithe 6 kwelicala noba nithe 6 kwelicala ku-carbon 5 kukho i-methyl people ne so I'm just gonna say 6 kwelicala so by the way you don't have to number when you name when I'm just doing it for you Lendo. The main continuous chain has 6 carbons yes and we have a methyl where in carbon 5 so this is going to be 5 methyl hex because the main continuous chain has 6 carbons hex but ku carbon 2 there's a double bond a triple bond so a hex 2 ine then siya ku 12 same story people basically what is important here we prioritize a double or triple bond over a branch people ne so kanibalayo apha kufuneka ngiqala ngabelicala 1 2 3 4 5 6 7 reason I have to start kwelicala ngapha because the triple bond is closest to the left hand side and then I branch yami ndoni methyl here is the branch methyl what is the name what carbon is it located 6 so 6 methyl hept causing 7 main continuous chain hept 3 triple bond is a carbon 3 ine yeah 6 methyl hept 3 ine let's go to example 13 no this is not 13 that's 1 2 3 4 5 6 7 8 9 10 11 12 13 yeah example 13 yeah so now we have 2 branches and a triple bond again when we count if I count from the left hand side 1 2 3 triple bond with carbon 3 if I count from the right hand side 1 2 3 triple bond carbon 3 but now notice if ever I draw a line here substituents zam okanye alkyl branches zam is located to the far right hand side so when I count position of triple bond is a carbon 3 either way no one left no one right so I'm going to prioritize the next best thing which is the methyl groups here so I'm just going to start from the right hand side it is 1 2 3 4 5 6 out and you look at what you must prioritize remembering that functional groups, they take priority over alkyl groups, because alkyl groups, if ujongile pha phezulu bendithe your functional groups zona. Remember, I emphasize le nto uba ezi functional groups, these ones are not, they are not functional groups. So going back to example 13. Example 13, because now I've started on the right hand side, it means carbon 2, I have two methyls. Now this is very interesting and unique. When you name, mention a position ye branch or side chain. So andizuthi phana 2 dimethyl, apparently rules zethu zisixeba if there is an identical alkyl group or substituent in the same position, we must mention that position twice. So kasi mention asizothi 2.2 dimethyl. Emphasis, people, you mention it twice. Nobu uzofakela udayi, yazi uzofakela udayi, but phinde uyimention. Nobu uzayidayi phinde uyimention ne. So 2.2 dimethyl, main continuous chain 6 hex. Hex kukho i-triple bond pa where it is closest to carbon 3 triple bond ion. So this is a 2.2 dimethyl hex 3 ion. 14, dead now. Okay, now let me dictate. In this molecule, there's no branch here. Why? Because I can count here continuously without skipping a carbon. I can say, starting from the left hand side, 1, 2, 3, 4, 5. That is continuously because I did not skip any carbon. This is not a branch. Ayo branch le. And ya banga emphasize njani ndizaphinde ndimcacisele pha message endizayithumela kuni. Ayo branch le. And then if ever you check starting from the bottom here, 1, 2, 3, 4, 5, still there's no branch. However, now we can't start from that side. Why? Because a functional group here must occupy the lowest number possible. So the lowest number possible, people said 1, 2. Nansia. Kandi low carbon 2 agana double bond. So 2, 3, 4, 5. And then in doing lena, he penned because of 5. Penned, where is the double bond? 2. Penned in because it's double bond. Example 15. I think I'm here. Example 15, and thereby into baby for me emphasize up. Let me check. Oh, I see it. Remember, rule 2, very important here. The longest continuous chain must contain the functional group. In other words, as kwazi uti apa people. If 15, very important, arguably one of the most important examples here. As was with 1, 2, 3, 4, 5. Apane, we cannot do that. Nor can we do this 1, 2, 3, 4, 5. Even though this is the most carbons possible in this chain, but kumbula, itila rule, the longest continuous chain containing the functional group. So this double bond has to be part of the main continuous chain. So kanibalayo nyanzelekile ngiqale ngapha because carbon 1 it's closest to carbon 1 functional group yam. And then I can either go 2, 3, 4 where I have a methyl carbon 2, or I can go this side 3, 4 where I have a methyl carbon 2 again. And if you're listening, it means that either way, at carbon 2 I have an ethyl, so it does not matter. Then when I name, I'm going to say 2 ethyl because there is an ethyl with carbon 2. The main continuous chain is a bute, but now carbon 1 there's a double bond, so bute 1 in 16. Okay, so let's go to the rule because basically rule I forgot. Basically rule 4 ne? Now let's add our rule 5 for halogens. Rule 5 for halogens or alkyl halides. Again, people, now as a halogens ne? Fluorine sitting with fluoro, chlorine sitting with chloro, bromine sitting with bromo, iodine sitting with iodo. Ne? I remember teaching you this. So upper is going to be like a more advanced version of what we did. Basically, what is being emphasized with rules, I'm not going to read the whole thing, but what is being emphasized is that if ever you have multiple halogens, if you're identical, kumbula, bazi 2 uzoti difluoro, dichloro, dibromo, diiodo, yabazi 2. Then if uzi 3, if uzi 3 uzati try nansi muslento ya apply nalapha lento try. If uzi 4 utetra ne. However, they can be mixed. If uzi mixed halogens zakho, now kuzofuneka apply no rule 5. I mean rule 6. Rule 6 uthi basically, I'm not going to read the whole thing, but he apply, okay man, read the part. It branched groups halogen atoms in alphabetical order. Put in alphabetical order. Qala ngale itheni iza alphabetically qala. Then nansi enye part endifuna add mna ignore lento xa apply ntoni xa apply i-alphabetical rule. Ignore. Utry somfaka uthi ba utry uzaqala no tetra, utetra uzaqala no di, yonke laa nto. Do not apply that. Apply nje for upromo ba apha xa ndijonge apha ezi letters zizaqala apha. U-B uzaqala ibe ngu-C, ibe ngu-I, I mean say ibe ngu-F, ibe ngu-I. So that's what you basically have to do. Let's go to the example so that explain a little bit what do I mean by that. So upper, where is it now? I have multiple atoms here, halides, alkyl halides ne. Nazi Z3 ne. Ubromo no fluoro. Siza apply thina into ethi ba between u-B no F yeyiphi ezaqala kwi-alphabets. Asuzo apply ba lena ingubromo, so izaba ngu-di. Asuzo apply lo, apply ba between u-BR, I mean u-B kabromo no F kafluoro kuzephi kuqala. Basically kuzu-B bantu ndizobe ndifundisa wena alphabets. Kuzu-B, so it's going to be what? B first. And then we apply rule yethu. They recognize these are our functional groups, by the way. And then masibalayo masibale such that if carbon lowest, it has that functional group. So anobala ngapha people obvious because apha kweliqala kanqala kweliqala carbon 1 nayo functional group la BR 2 3 4 ne. And then now when I name, notice u-B, so qala ngaye but u-B by 2 BR. So when I name, I'm going to say 1, 3. Apply la nto bendicela yona di ntoni bromo. But khumbule alphabetical uqala apho apply udi kangendawo into alphabetical. Dibromo, then the main continuous chain is 4 carbons, so ngu-bute. Oh no, asikagqibi. Dibromo, carbon 3, fluoro, then bekhona sigqibezela i-stem name okanye i-main continuous chain, parent chain, butane. So yi-1.3 dibromo 3 fluorobutane. Let's try another one. Okay, yeah, let's put it here. Let me check 16. So this is example 17. Let me go back. Read another rule. La part is very important. Combined elements of the same name into a single word. Elenity upper. If ever you have branched groups and halogens or halogens, put them in an alphabetical order. Place them in an alphabetical order. It ignore la prefix lingu die okanye lingu bani lingu tetra okanye tri ne. So let's go back. Ayithi lento ba funeka kuxubane halogens zodwa basically people. Ayithi makuxubane halogens only. Lento siyakwazi ubana ntoni because if uyakhumbula i-substituent yi-halogen okanye yi-alkyl group. So nansi umzekelo apha sixubile apha because sine-methyl and also a halogen. We still applying intoni i-rule ye-alphabetically. Mjonge now sine methyl nantoni ne-iodo. Let me just use a small letter iodo. Nawe ke ucinge ba between u-I no M kuzabani. Okay, so now and then we count the functional group yalapha kubani people. Functional group yalapha, it has to be, let me use a color that's going to contrast. It has to be, oh my god, it has to be the halogen. Kumbula bente methyl is not a functional group, not a functional group. That makes this an alkyl halide. Ne? Because this is an alkyl halide, it means that I must trace that halogen such that it occupies the lowest number possible. Carbon yayo occupies the lowest number possible. So 1, 2, 3, 4, 5 people. Ne? Yeah, the longest continuous chain again. That is why I was going to 4 up. Because this is this is not the longest continuous chain. So 4, 5. Oh my god. 5. So now when I name the molecule, I have to start now with the position of iodo. Why ndiqala ngo-iodo? Because I uzaqala no M. So I'm going to say 2 iodo. DT3 methyl pentane. So 2 iodo 3 methyl pentane. See for example 18. The final example, ne? Basically simply identical functional group or halogen, chlorine. One is located in the first carbon from the left hand side. The other one is located in the fourth carbon from the left hand side. So basically from the left hand side up. So 1, 2, 3, 4, 5, 6, 7, 8. And then when I name 1, 4 dichloro. The main continuous chain has 8 carbons, so 8 is going to be chloro-octane. Octane because haloalkane. So 1.4 dichloro-octane. I am stopping the lesson here. If ever unombuzo ungabuza egroupini, Otherwise, this is as far as I can go now.